pyruvate inhibiting the pyruvate kinase. Yes? Also citrate inhibiting the pyruvate dehydrogenase. Yes? So citrate inhibiting, acetyl-CoA inhibiting, yes, acetyl-CoA inhibiting, ATP inhibiting, pyruvate kinase, okay? Activator, fructose 1,6-bisphosphate. Okay, so pyruvate kinase regulated by hormonal regulation and electric regulation. Electric regulation, fructose to 1,6-bisphosphate. It is activator, ATP inhibitor, acetyl-CoA accumulation is inhibitor, and alanine is inhibitor for pyruvate kinase. Okay, pyruvate kinase is very important for ATP production in red blood cells. Yes, so any inhibition or completely blocking the activity of pyruvate kinase will lead to hemolytic anemia. Yes, hemolytic anemia. Why? Because the shape of red blood cells will be changed. Shape of red blood cells will be changed. Why? Because of the accumulation of sodium in cytoplasm of red blood cells. Concentration of the sodium, yes, and potassium electrolytes in red blood cells regulated by sodium-potassium ATPase pump. And sodium-potassium ATPase pump is the pump which is dependent on ATP. And only ATP produced in red blood cells is from glycolysis. It is only from the activity of pyruvate kinase. So any blocking or mutation in pyruvate kinase will lead to hemolytic anemia. So rapid destruction of red blood cells. Why? Due to accumulation of sodium. Sodium will change the shape of the red blood cells. Red blood cells becomes less flexible. Less flexible. Yes. So red blood cells, normally it's flexible cells. Become rigid. Swelling. Swelled cells. Changing shape of red blood cells. Hemolysis, rupture of cell membrane. Yes? Okay. So these are the regulatory enzymes of the glycolysis. كذلك المحاضرة الماضية كذلك inhibitors for glycolysis. Inhibitors for glycolysis, number 1, iodoacetate. Iodoacetate inhibiting glyceraldehyde 3-phosphate dehydrogenase. And arsenate. Arsenate causing bypassing energy. Yes? Fluoride is inhibitor for enolase enzyme. Yes? Bromo hydroxy acetone phosphate is inhibitor for triose isomerase. So dihydroxyacetone phosphate cannot be converted to glyceraldehyde triphosphate. Oxalate is inhibitor for lactate dehydrogenase. So oxalate inhibiting the Curie cycle. acetyl-CoA. Accumulation of acetyl-CoA activating the pyruvate kinase. How? Yes, this is pyruvate. Pyruvate dehydrogenase. NAD to NADH. Yes. Decarboxylation. Carboxylic group release. CH3. CO is CoA. Acetyl-CoA. Yes? Okay. Acetyl-CoA, it is activator for pyruvate carboxylase. Pyruvate carboxylase. البيروفيت carboxylase. pyruvate carboxylase. هذا الأستيكو إيه؟ pyruvate carboxylase. Yes. Carboxylation of pyruvate oxaloacetate. COOH, CO, CH2, and this is the carboxylic group. Oxaloacetate. Oxaloacetate with the pyruvate, yes, forming the citric acid. Citrate. COS, C. Citrate. Okay. The source of pyruvate is phosphoenolpyruvate. Pyruvate kinase. Yes? ATP to ADP. Yes? Sorry. ADP to ATP. Pyruvate kinase. Yes. So, activation or accumulation of acetyl-CoA just will activate the pyruvate kinase, pyruvate carboxylase, pyruvate kinase. Yes. So this reaction and this, yes, pyruvate, pyruvate carboxylase. Okay. But when there is low oxaloacetate, yes, source of oxaloacetate is mainly carbohydrate, yeah? Glycolysis, pyruvate carboxylase, oxaloacetate, tripside. So when there is low carbohydrate, low oxaloacetate, acetyl-CoA accumulated, inhibiting the pyruvate dehydrogenase, pyruvate accumulated, yes, pyruvate kinase. Okay? فهمت كيف الريجوليشن حاليا؟ So, okay. So the acetyl-CoA can activate. Yes? Availability of pyruvate. So acetyl-CoA activating the pyruvate carboxylase. So في حالة glycolysis, enough glucose, acetyl-CoA it is activated. So when the glucose level decreases, pyruvate decreases, acetyl-CoA. Yes. Okay. لأن في another source of acetyl-CoA, it is fatty acids. لو فرضنا أنه هو 18 carbons, stearic acid, yes. How many carbons? Acetyl-CoA. 2. So stearic acid catabolized to 9 molecules of acetyl-CoA. Accumulation of acetyl-CoA. Yes? Oh. Feedback inhibition. Pyruvate inhibited. Yes? Krebs cycle. No. Oxaloacetate cannot enter the Krebs cycle or convert it to ketone bodies. Okay. So, can inhibit, can activate. It is depending on availability of substrate of glucose. So, في حالة glycolysis, the acetyl-CoA activating. But when the blood glucose level decreases and decreased glucose decreases in cytoplasm, the acetyl-CoA will inhibit. Yes? Because without oxaloacetate, the acetyl-CoA accumulated. صح؟ إذا كان ما فيش acetyl-CoA مش هتحول ستريت. acetyl-CoA accumulated will inhibit pyruvate dehydrogenase. Yes? Pyruvate dehydrogenase inhibition will lead to accumulation of pyruvate. Pyruvate accumulation, feedback inhibition, pyruvate kinase. Yes? So it is depending on situation. Okay. Okay. صارت هي الريجوليس. قلنا الانزيم inhibitors or الانزيم foreign body inhibitors for the glycolysis. Oxamate inhibitors for lactate dehydrogenase. 1-bromo hydroxyacetone phosphate inhibitors for triose isomerase, and enolase inhibited by fluoride ions. Okay, and iodoacetate is inhibitor for the glyceraldehyde triphosphate dehydrogenase inhibition. As arsenate causing bypassing energy. قدرنا كيف عرفنا كيف bypassing energy. ليش؟ لأن لأن الجليسر الدهين تريفوسفات to 1,3-bisphospho glycerate. So Bi group entering the reaction, ADP, NAD to NAD. Yes? Glycer aldehyde 3-phosphate dehydrogenase. When there is arsenate, arsenate. Arsenate will substitute in organic phosphate. ASO3. Substitute. So no inorganic phosphate will enter in the reaction. So arsenate will enter in the reaction, forming 1-arsino-3-phosphoglycerate. Normally, 1-3-phosphoglycerate converted to 3-phosphoglycerate. One phosphate group transfer to ADP to ATP. Yes? Glycerate? Kinase, yes? But in case of 1-arsino-3-phosphoglycerate, the arsenate release it. Yes? Spontaneous reaction. Spontaneous reaction. It is not enzymatic reaction. Spontaneous reaction. 2,3-phosphoglycerate without the production of ATP. So bypassing energy. We lose energy. Bypassing energy. So in case of arsenate, toxicity by arsenate, the energy produced from the glycolysis will be less than in case of absence of arsenate by 2 ATP. Yes? By 2 ATP. Bypassing energy. Okay? Okay. Hexose monophosphate pathway. تعرفنا ان السورس of energy in our biological system by 2 pathways. Number 1, by electron transport chain in mitochondria. Number 2, by direct phosphorylation of ADP to ATP in cytoplasm on mitochondria. Yes? So it is substrate level phosphorylation. Direct phosphorylation of ADP to ATP, سموها substrate level phosphorylation, or by electron transport chain. So how many substrate level phosphorylation in a glycolysis? 2. Yes? Glycerate kinase and pyruvate kinase. So we're getting ATP without the helping of the mitochondria. Direct ATP. Yes. In mitochondria, NADH will be oxidized to NAD producing 2.5 ATP. Yes? FADH2. No FADH2 produced in glycolysis, yes. But NADH oxidized and produce 2.5 ATP. Okay. The hexose monophosphate pathway the aim of hexose monophosphate pathway is different from the aims of glycolysis. The aims of glycolysis mainly ATP production. Yes, mainly ATP production. But the intermediates of glycolysis can be used in anabolism. For example, dihydroxyacetone phosphate can be used in anabolism of the TAG, triacylglycerol. It can be used for synthesis of phospholipid, glycerophospholipid, and 1,3-bisphosphoglycerate can be isomerized to 2,3-phosphoglycerate. 2,3 bisphosphoglycerate, decreasing the affinity of hemoglobin A to oxygen, but increasing the unloading or delivery of oxygen to peripheral tissues. Yes? So, from glycolysis. But it is not the main aim. The main aim of the glycolysis ATP production. Hexose monophosphate pathway. Monophosphate pathway. So in glycolysis there is diphosphate. Yes? Diphosphate. In hexose monophosphate pathway there is no diphosphates compounds, yes? Only monophosphate. So hexose monophosphate pathway, or pentose phosphate pathway. In glycolysis there is no riboses or pentoses produced. And the pentose phosphate pathway, ribulose, xylulose, so there are classes of pentoses, aldopentose or ketopentose. Xylulose, ketopentose, and ribose is aldopentose. And can be called as phosphogluconate pathway. Not in all cells. Not on all cells. So this process active in liver, adrenal gland, and the kidney. Yes, less active in skeletal muscle. Yes. Okay. What is the aim